Hey, Professor Tippins. This is Elijah here. I want to point the camera at myself. I don't know if you can see me. I have to record from my phone this time because I have to show you the board. So after much trial and error, my frantic email that I sent you, and my VHDL messing up on my laptop, I have now went to my friend's desktop, used my same code, signed into everything, and we are good. So without further ado, here's my code. Elijah, date it was created, module name, again, a description just telling me what the project is. And I'm going to start keeping revision in the comments because I want to know how many times I come back to this. I'm working hard. So there's no more going to be no more 0.01. I'm going to see how hard I start working on this. Here's my entity. So here's just SW, LED, seg, and AND. Now, SW obviously switches, LEDs, segments, anodes. I kept it like the basic names. So that way when I went into, where's that? The basis file, right here. This is so weird. The basis file. That way I can just keep the basic names already in here. So I uncommented 0 to 7 for my switches. And you know, it's already SW as a vector. It's already LED as a vector. So uncommented that. My 7 segment display. My anodes. And then of course, you know, the only other thing uncommented is your power at the bottom. So cool. Now, I don't know if you can see the color through my phone right now, but anyway, here's the architecture, constant right seg. So this is just what you were telling us about in the lab video. This is just making sure that it's on the right segment of the display. So it's the anode part where it's on the right, making sure that it's how we read it normally, which is pretty cool. And then constant LED on, so it's just a high to be on. And then my switch is a high to be on, so that's just pretty standard. Never hard code values. Professor Tippins taught me that. So here are the LEDs, here are the constants, and then here are the values from 0 all the way up to everything being filled, 7 down to 0, 0 all the way to 7 up to 0. And here's your 7 segment display. Again, this is, this isn't the value, so this is how I displayed it on my board, how the value should be displayed. So that's pretty cool. I think my phone went on battery mode because it's gray now, so congrats to me. Here's the begin statement. Here's the anode right seg as I declared earlier. So just declaring anode the right seg. Made a switch count so I could count all my switches, 0 to 7. 8 switches. I was talking to my friend and he was telling me about the variable count, the range. I don't really remember us going over that too much, but he helped me with that. So the range is from 0 to 8. After that, I begin and I have my count statement. So I have if switch 0 is on, then increase count plus 1. Obviously, I just keep doing that. Pretty simple. You had that in your code. And then I have my case statement. Segment is equal to 0 LED. Segment is equal to 0 on the 7 segment LED. And LED 0. And of course, you just keep going. You also have that in your code, which is pretty self-explanatory. In your process, I have my test bench. So I have my name, pretty much everything the same. Description's a lot smaller. I just made sure I remember that we're only testing for 9 output conditions. So we're not testing for all 256 input conditions. So if I ever come back, I'll just know, hey, this is when I go to the simulation, this is why I see what I see. I'm only testing for 9 values. So I just put that in there, which is pretty cool. After that, I scroll down, have my architecture, I have my component. You can see the port, that port map. So switch 7 down to 0, LED 7 down to 0. Have my signals. Everything's pretty self-explanatory. Is there anything else I need to explain? Here are my switches. I talked to a student who had been in your class before, and he said that you like the values to be a little bit random. You didn't like them to be in order. So I randomized the values. But I can show it to you in the video. The values are still, it's still from the top to the bottom. It's just they're randomized. So as you see, the ones are in different places for us different. That's all that is basically. I already ran my simulation, so thank God. Let me see. It's looking gray on my phone, so I gotta make sure you can see this. But basically, here are my LEDs. I open them right all over here. So I open everything up, open my LED up, and then open my switches up. So as you can see, my LEDs go from 0 to 8, like they're supposed to. And we'll stop right there because that's all we're doing for this project. And then we go up to the switches. And as you can see, my switches go from 1, 2, 3, 4. So the ones are in random places, but it still goes up like it's supposed to. So when I have 8 switches on, all 8 LEDs are on. When I have 7 switches on, all 7 LEDs are on, and so on and so on for all of them. So that's pretty good. So that's how my simulation works. Now, if you bear with me just a little bit, I'm gonna close this out. Don't need to be taking up memory. I'm gonna go over here, generate bit stream. So that's loading up. Still loading, still loading. Okay, there it goes. I had to turn my bedtime mode off. That's really weird. Everything's back in color now. Professor, we can pause the video. So I'm going to do that magical thing where next time you see the video, everything's already done loading. We're back, Professor Tippins. So here's what I'm going to do. Turn the board on like that, so everything's loading up. It's pretty cool. Project manager, still running. So I'll pause it again. And magical, we're back, Professor Tippins. See, like I saved your time. Okay, so I'm gonna open the hardware manager and wait for that to load. We're gonna open the target. Auto connect, of course, of course. Program the device, programming. And voila, Professor Tippins. So here it goes. I know it's a little bright, Professor Tippins, so bear with me with the LED. I know it's kind of weird because it's not the human eye, but here's a 1. Here's a 2. It's really hard to see it because, you know. Here's a 3. Here's a 4. Here's a 5. Here's a 6. Here's a 7. Here's an 8. If you notice, if I put one of my switches down, it'll go down. So every switch has to be up like you want it. And I can just go back down. Yeah, that's really weird. You have to get that close. But anyway. Yeah, Professor Tippins. So everything worked out. So thank you, Professor Tippins. Have a blessed day.